I recall calculus 1, calculus 2, and compares with the calculus 3. Okay, in single variable calculus, single variable. Calculus. Wow. We have, for example, a function f of x equal x squared plus 1. Esa parábola. Entonces, I need to see the graph. I need to see domain. And I need to see range. Esa es la que cola álgebra. The graph is obvious that we are doing in 2 dimensions. 2D. XY. The domain, no. The domain is only 1 dimension because domain is the set of the x value in which the function is defined. By the way, in that case, a real number. Okay, it's the same supposition, guys. The supposition is, remember, domain you suppose is a real number, except restriction. Restriction. And the classical restrictions is always the same. Is when you have, for example, division, the expression in the denominator not zero, because division by zero is completely undefined. A radical expression, the expression inside the radical must be non-negative, so positive or zero. And when the expression is in the bottom denominator, the restriction is positive. We have more restriction. We have, for example, we have logarithmic functions. Logarithmic function que es el logaritmo of the any expression. The restriction is expression inside the argument of the logarithm must be positive because logarithms do not accept negative or zero value. And range is again 1D. In this case is, well, let me write it like that. Is y value, no? This is the y value. I know the y is a vertical axis, no? But okay, it's a y value in which the function give me answer, right? It's the idea in single variable. Easy. A multivariable. Calculus. Well, we have basically 2 possibilities. We have the function que contain 2 independent variables. For example, x squared plus y squared. And we analyze exactly the same idea. We analyze graph, domain, and range. And the graph is obvious que es 3D. In the famous x, y, z axis. By the way, mentally you replace the function notation that is g of x comma y like a c, no? That's another possibility. However, what is the difference? The difference is that domain is no real number, is r squared. So domain is x comma y because it's the Cartesian product and between 2 independent variables x and y. The domain is one subset of the R2. Okay, one to discover in one specific example. And you associate this order pair x comma y with the range. Okay, the range is c axis, right? One value here associates. Okay, it's 1D. This is 1D, this is 2D, and the graph is 3D. This idea is clear, right? But it's important you keep in mind because in the problem we are doing now, I give you one function multivariable that contain two variables, two independent variables, x and y. And I ask you find the domain. No? You see, I need to understand that the domain of this function is living in a two-dimensional plane, right? X, y. And the range, is only real number, no? Except in the vector value function, que es special, no? Vector value function, remember, is a function que the range is a vector. Pero no. In this case, is a function of several variables. And the several variable is independent variable. And that's it. No. We have another possibility case. For example, you have another function que I want to call age, que depend on three variables. For example, x squared plus y cubed plus c. In this case, the consideration is that x, y, and z are independent variables. Entonces another dependent variable que in function notation I call like h, pero in variable I call maybe w. And w is dependent variable that depending of three independent variables, x, y, and z. Entonces the graph of this is impossible to do because it's 4 dimension. Why 4 dimension? Because we have 4 components, no? We have 3 independent variables and 1. So basically, any point inside this function represents the 4 components, no? X, y, z, w. Entonces now in our classical 3 dimension, it's impossible to represent that. Let's see how we can do something, no? There are several ways, but we can do something in 4 dimension. But in this case, no graph. No graph. And the domain is obvious que es R3. O sea, the domain, si I ask you find the domain of this function que contain 3 independent variables and 1 dependent variable, es obvio que the domain is solid. O sea, es 3D, es a solid in which x, y, and z, when you plug it in inside the function, give me a value, no to be undefined. Not to be undefined. And the range, when you associate any point here, no surface guy is solid. Okay, it's solid, is in the pill, so outside surface area or inside. 3D, x, y, z. X, y, z. X, y, z. And you also say any point here with W axis. 1 point. The range is 1D. And the domain is 3D. And the graph is 4D. And 4D we cannot represent. Do you understand the idea? We have more than 4D. Of course we have more than. So it's more crazy, no? In the same measure. Is the range always 1D? Good question, David. It's always the range 1D. Super good conclusion. Except in the vector value function. Pero no. In this chapter, no vector value function. Okay, it's always 1D, the range. Let's see example to practice this idea. Is very, very easy. It's no big deal. I give you, for example, one function and you determine domain and range, or domain and range. Okay, suppose example 1. Look, example 1 is the function is f of x, y, equal x times y divided by x minus y. Entonces, aquí sí, wow, we have two independent variables. O sea, two independent variables. Que they are x and y, no? Therefore, my domain lie in the plane R2. Okay. The assumption is always que you suppose que es R2, except the restriction. I need to investigate restriction. And the restriction is obvious. Restriction, you take the expression in the denominator, que es x minus y, and this is no zero. Okay. Therefore, this is x not equal y. So any point on the plane satisfy this condition except the point que have the same component x comma y. Okay, by the way, this is the line, that line can be set the first quadrant and the third quadrant. Okay, and the rest is okay. Any point que don't lie on this line belong to the domain. The only guy gets restriction, gets completely outside. And we can, for example, represent graphically the domain, or when you write like that, domain is equal is the order pair x comma y, such that x no y, no equal y. This is my domain. And the range, well, the range is every number that you plug in here, here, of course, not in the line, give me one answer, and this answer is all real numbers. Clear? See, I ask you dimension of domain is 2. And this is clear, look at that, 2 dimension in xy plane. Dimension of the range is 1. And the range you don't see here, you can do in another line, que es z. Is c. Oh, this is 0. And normally in the function notation, c is equal f, x comma y, no? Entonces you associate one number here with the one value here. You plug in here and you compute that. Idea clear? It's easy. This is look like color algebra, but a multivariable. Now example 2, a little bit more interesting. Example 2. Example 2 is, suppose the function f of x comma y equal square roots 4 minus x squared minus y squared. Entonces, again, the same idea is compute domain and compute range. Okay. And you suppose that the domain is R2, or at least one domain is one subset of the R2, because we have 2 independent variables, no? And the restriction is when you take the expression inside, is 4 minus x squared minus y squared, and this expression must be non-negative. Okay, so now for example, I'm moving negative x squared minus y squared greater than or equal -4, multiplication by -1, everything, or divided by -1 is the same, -1, -1, -1. When you're doing this action, it's x squared plus y squared, 4 positive, but this is now less than or equal. Remember, in inequality, when you multiply or divide by negative numbers, the sign of the inequality is reversed. Okay, cool. Entonces, identify clear que our domain is a this. It's a this. I said this because you understand this like equation, you temporary in your mind, you forget less than. This is the circle, and the circle with the center is the end, the origin, and the radio is 2. 1, 2, 1, 2, 1, 2, 1, 2. It's a circle. But when you consider less than, it's obvious que es the surface inside the circle, including the circle. The circle is included inside this because it's equal. Entonces now this is graphic, one possibility to indicate domain, or like that, domain is equal the x comma y such that x squared plus y squared is less than or equal. Boom. Cool. Now the range. Well, actually, guys, let me see. To investigate the range, you suppose this is a function notation. However, this is z. It's all with the supposition. So my function is z equal square root 4 minus x squared minus y squared. If you square both sides, you have z squared is equal 4 minus x squared minus y squared, because the square and the square root together cancel out each other, right? Now, so you organize a little bit more elegant this quadratic surface is x squared plus y squared plus z squared equal 4. Wow. And you identify perfectly that this is a sphere. A sphere. A sphere where the center is located at the point 0, 0, 0, and the radius is 2. And it's matching perfectly with this idea, no? But in 3D. So in 3D, actually, the function gets given at the beginning. So you put in the algebra or one graphic calculator, you see something like that. X, Y, and Z. You see spheres. Look at the sphere. But actually, it's not full sphere. It's a hemisphere. How do you know the hemisphere? Because somebody know me, isolate the z value, you apply a square root, and you default when you see a square root, you suppose it's positive z, not negative z. And you find the square root, normally so you put plus or minus, I suppose it's the upper half of the sphere and negative is the lower part of the sphere. But you don't write plus or minus, you write like that. It's because I suppose default gets the positive part. That actually is the hemisphere. The hemisphere, this is exactly the circle, no? Okay, we have here in the domain. But in 3D, we have hemisphere. Okay. No, the bottom part, no. The bottom part, no. Okay. No. It's only the positive part. Now, you can see now a little bit more clear that our range R is that part, the C value. And the C value is from 0 to 2, because the radius is 2, no? Okay, the range is the Z value, such that C is in between 0 and 2, include both. Okay? More clear or no? Example 2 is okay? Clear, super. Let's do it 2 more. And that's it, enough. Okay, example 3. is f of x comma y is equal square root 100 minus 4x squared minus 25 y squared. Again, we have in front of one function that contains two independent variables, x and y. The graph of this is in 3D. However, the domain is in 2D. The range is in 1D. Okay, I have no idea. However, immediately I replace the function notation like a z. This is the convention of the name of the variable, no? Always, in any book, in any course of the multivariable calculus. Now, again, you apply square root both sides. So we have c squared is equal 100 minus 4x squared minus 25y squared. You organize the equation, you try your best, putting a standard. So I, for example, I move everything to the left. You organize in alphabetical order, no? 4x squared plus 25y squared plus c squared equal 100. Now, in order to express in standard, you divide by 100 everything. 100, 100, 100. 100. Because I would like the right hand side must be 1, no? That's x squared over 25. So 100 divided by 4, no? 100 divided by 25, 4 y squared over 4 plus c squared over 100 equal 1. And you identify quickly, wow, it's an ellipsoid, right? It's an ellipsoid. So you write like that, x over 5 squared plus y over 2 squared plus c over 10 squared equal. It's ellipsoid. But domain, you consider only x and y. I know very well that the domain is subset of R2. Entonces in that case, es obvio que es elixir, right? Elixir, what kind of elixir? Es elixir, es a horizontal elixir. Like that. And this distance phi, because A phi is the major axis, like the phi. And the minor axis 2 on the y, 2 and negative 2. Okay, cool. And the domain is this region inside. The reason it's inside is clear. It's similar, no? Because in order to guarantee that the expression inside the square root is, okay, look, let me show you. Take this, and you write 100 minus 4x squared minus 25 y squared must be non-negative. Okay, cool. Yeah, you minus 4x squared minus 25 y squared greater than or equal to negative 100. If you, for example, divide by 100 or negative 100, everything, negative 100, we have x squared over 25 plus y squared over 4 is less than or equal 1. This is elixir, and the area enclosed inside the elixir is this, and this is our domain. So one elegant way, no, to indicate graphically is good to visualize. I like so much graphic. However, you can write domain as every ordered pair x comma y such that satisfy this condition, and you copy this equation, or you copy, for example, in my paper I copy this equation: 4x squared plus 25 y squared less than or equal 100. Oh, another student said, no, I like this way. Okay, no problem. You copy this. It's equivalent 100%. This is my domain. However, what about the range? Well, the range is, I come back here, I anticipate a little bit with the 3D. Entonces en 3D, I suppose que es elipsoide, ¿no? And this ellipsoid is well, in this case 5, 1, 2, 3, 4, 5. In this case 2, 1, 2, and in this case 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, ellipsoid like that. Okay, this ellipse is similar to this, but in the z-axis we have something like that. Okay, as you take a look, for example, this is 3D complicated. So you take a look, for example, to the picture, but no this xy. It's a 2D, of course. Is xz, because I want to see the z value, no, the range. Entonces en x es 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, negative 5, no, negative 5, but this is 10. Entonces es 10, pero 10 in both directions, positive or negative. No negative, because again, repetition, the same idea. Ellipsoid is both positive and negative. However, my problem only consider que C is positive value because it's inside the square root, and also do not indicate plus and minus, only indicate nothing, and nothing default, you suppose it's plus. Therefore, the range is the C value such that C is in between 0 and 10. Okay, it's that part. Let me highlight that part, or that part in 3D. Clear? Clear? Nothing, no beating. Confusion. Hey guys. Clear. Okay, good. Let me erase. We have one more, and that's it, of that part of the domain range. Example 4, no? 1, 2, 3, 4. Example 4 is f of x is equal minus square root x squared plus y squared minus 4. No idea. Well, okay, you suppose we have two independent variables. I suppose the domain is subset of the R2. You take the expression in the denominator is x squared plus y squared minus 4, and this expression must be non-negative. You know, si es negative, it's imaginary, no? So to avoid imaginary, you write like that. So x squared plus y squared greater than or equal to 4. Okay, let's do graphically. xy. This is circle. Oh, no, actually no circle. It's a disc. It's a disc. Center and the origin and radius 2. 1, 2, 1, 2, 1, 2, 1, 2. Okay, but in this case, it's greater than. This is greater than is no inside the circle, it's completely outside the circle. This is my domain. Okay, this is the graphic representation of the domain. Include the boundary? Yeah, of course, include the boundary because equal sign is that part. Include this. Cool. Cool. How you indicate algebraically this idea? Domain is equal the order pair x comma y such that satisfy this equation. End the story. Okay, what about range? To analyze the range, you take a look the view in 3D because the range includes z. This is z. So my equation is z equal minus square root x squared plus y squared minus 4. Now you apply square power both sides in order to eliminate the square root. You square both sides, you have a c squared is equal minus, square negative become positive and disappear the square root. And we have x squared plus y squared minus 4. Let me organize in elegant way. So it's 4, you put a 4 here, you put a 4 here, 4 is equal x squared plus y squared minus c squared. And you see now, well, if you want to divide by 4, you want to express in standard, ¿no? Entonces, let me interchange. I put x squared here. To put in elegant way, no, to visualize plus y squared over 4 minus c squared over 4 equal 1. Cool. Entonces, immediately identify que this surface is hyperboloid 1G. Hyperboloid 1G. By the way, along CX. You remember CX is the axis, it's different, it's negative. Okay, entonces now in 3D picture, X, Y, Z. Okay. We have in the XY I did before a circle. Remember very well that the circle is the radius 2 at the center here in the origin. So you know that the hyperboloid, look like that. Right? However, in the original problems, remember we are doing transformations, and you take one expression that you are familiar, no? Que is the hyperboloid. However, you come back at the beginning and you say, wow, but it's negative. That means que our figure in 3D is that part, the negative part, no the positive part, that part. This is 3D. See, we are doing the graph in 2D to see more clear. And you suppose, for example, this is the x-axis and this is z-axis. This is a lateral view, guys. This is my eyes. Look, I take a look in 2D like that. I see hyperbola. Okay, hyperbola. Because you consider, for example, the y is 0. That part disappears. And we have x squared over 4 minus c squared over 4 equal 1. And this is the famous hyperbola, no? In 2D. Hyperbola. But the most important is no si es hyperbola o no, sino que the range is that part. The negative part. Entonces the range would be range is C value such that C is, bueno, you know, is negative. Entonces include 0, of course. Es X x, no, c, sorry, c less than or equal 0. You can this interval or region we can use in, for example, this notation. No? Okay, some students say, well, no, but I don't like this way, it's confusing for me. Okay, so you put ranges, brackets, bracket, no, parentheses, negative infinity, comma, 0, bracket. There's another possibility to express this, and this is equivalent. This is set builder notation, and this is interval notation. Either way, this is more complicated. Entonces, that is the que en one dimension problem is, in my opinion, no, it's better interval notation. However, in more than one dimension, 2 dimension or more, it's better set builder notation. Set, this is call it set builder notation. I suppose that you are familiar, no, with this name. You see at least one time in your life, no? This name, and you're using your imagination. Suppose that you don't know very well the terminology, mathematical terminology. You write in English. It's all real number from 0 to negative infinity, all real number. Oh, here you see, well, this is the domain, is all the ordered pair outside the circle where the center is in the origin and the radius too. In English, and you get the same conclusion. Any questions so far? Any question? Okay, let me try to explain now. So you have no questions. This is easy. This is called algebra, a little bit. Huh? Okay. Let me try to explain one concept is, at least for me, hard to explain. Is, okay, let me try to start at the beginning. Level core. So I want to explain level core. I want to explain, I put the name of the concept I want to explain. Contour plot. I want to explain also level, but no, it's okay. So far it's okay. What is level curve? What is level curve? Well, this is one fantastic idea, because suppose that we have one surface in 3D, like that. So it look like a paraboloid or something, no? And now the engineer, the civil engineer, to analyze the topography of the land, apply this idea, level curve. What is the level curve? Suppose que it's a mountain. This surface is a mountain. Now you apply different level curve, and the level curve, this is the function que es f of x comma y, no? Que by the way is z. And you apply level curve que es, suppose que z is constant. C. Well, let me put constant like that. And c equal constant is different plane like that. Oh. And the intersection between the function, que is the mountain, and the different plane, give me something like that. And this is the level curve. Because we can change c. C equal 1, C equal 2, C equal 3, C equal 4. And we have a family of the level curve. So level curve by definition is, you suppose, f of x, comma y equal constant. And this constant is several values, 1, 2, 3, 4, 5, or negative, positive, or negative. So we have a family of the curve. A family of the curve. I promise in a few minutes, a few seconds, I want to show you more clearly this idea. And what is the contour plot? Well, the contour plot is a family. The contour plot is a family of the level curve. Is family of level curve. Okay. And you see, for example, you see the floor plan, and you see something like that. So I try to do my best, guys. The whiteboard, I try to fix it. Okay, you using your imagination. Suppose que dices que z equal 1, and this is z equal 2, and this is c equal 3, and so c equal 4, and c equal 5. Okay, so this family give me information about the surface. Entonces, what is the idea behind this? Well, the problem is que this problem is 3D now is converting in 2D. So basically reduce the dimension of the problem. This is the advantage of the level curve and the contour plot. Contour plot is the family. Level curve is only one curve, and contour plot is a family. I prepare for you. This is important, guy. Look like weird, but it's important. I prepare for you one script in GeoGebra, and after I want to analyze in the new software I want to present to you, guys, send the link in by the chat. Okay, look. Okay. I try to find GeoGebra script. Okay, I create for you in this chapter. Boom. Cool. Let me share the screen. Share screen. There you go. This is GeoGebra. Do you see GeoGebra? Wow. You see, wait, where is this? Here. Increase. Do you see GeoGebra? Yes or no? Cool. We have, let me see. I create this. Look, I have different plane here. One plane, we have one surface, of course. I create one surface. It look like two mountains. No? Now I put different plane, and here the implicit curve represent the intersection. No? Intersection. Look at the intersection. This is relatively easy to find. And now, in this slider, I put a hypothetical level. You see how when I change the level, you obtain different level curve. Indicate different level. If you want, for example, take a look. The most important I want to show you. I delete this plane. I delete this quadratic. I take a look on the XY plane. Remember, X is the red one, Y is the green, and this is the contour plot. Que give me some information, no super fantastic, but give me information about the one thing that's 3D you convert in 2D. And you see the application of this in your mind. This is the most important that you understand the concept behind this. For example, let me try. In the other software, in the other software. No GeoGebra anymore. I bring today another software. Let me show you this one. Let me see if you see or not. Let me share the screen to share to this. Switch into this. Do you see that? I provide you the link in the chat, guy. No, don't necessarily open now. You take a look and see my explanation. No? This is a little bit interesting. No, it's better than GeoGebra, but allow us, for example, contour plot is better. And also another thing we study, we using this. This is one more tool that we have online, free, no problem. I take this for surface weird. No, it's the very well known surface, you know. So we study only the quadric, but there are infinity possibilities of surface, no? In this case, you can see how we can doing super fast the contour plot. Look, you click here. You define different level here. Well, you setting here, but I go directly to the point. You create contour plot, and you see the contour plot. And when you click in the contour plot, you see now, wow, you see in the right part surface and contour plot, and you see here the contour plot in 2 dimension, yes, 2 dimension. Cool. Wow. You practice. No, now, of course. By yourself when you study, no? We can use in both GeoGebra or GeoGebra. The problem of the GeoGebra is you need to do everything from scratch at the beginnings. They have more sophisticated tools. For example, in contour plot, another thing that we study in your moment to see the 3-dimension graphic. Okay? That's it? No. We have more. Let me show you now. Let's come back to the whiteboard. Whiteboard now. Okay. Whiteboard now. Cool. Whiteboard. Do you see whiteboard now? Do you see or no? And we have another thing. Okay, let's call it. Do you see or no? Yes or no? You see? Yes. Okay, we have. Okay, cool. We have another thing. It's called level surface. Okay, I want to explain it then now. Now, of course, associated with this contour plot, but it's different. Suppose que I have one function in 4 dimensions. Remember, the most important advantage of the level curve is que reduce it here to here, reduce it the dimension. Entonces, bueno, professor, I have no idea. In 4 dimensions, we have no graph. But I need to analyze somehow this. Well, you apply level surface. What is the level surface? Let me try to bring one example to illustrate a little bit. Huh? No super, but a little bit. Suppose that we have function like that. X squared plus y squared plus c squared equal w squared. No, w, just w. For example, in the Einstein space, create the space in 4 dimensions to explain the relative theory. What is the 4 dimension? One of the 4 dimensions is the 3 classical dimensions, x, y, and z in the space and the time. Suppose que I replace no w anymore, t, like an Einstein space. In this case, we have function. This function contain 3 independent variables and t is dependent variable, I suppose. Because we are doing the graph. No, it's impossible because we are doing the graph in 3D. We have the classical x, y, and z axis, right? Entonces now we have no t axis. Where is the t? I don't know what is t. Entonces you apply the same idea for the level curve, pero now it's level surface, in which you suppose different value t equal 1, so t equal constant, so f of x, comma y, comma z equal a number, constant. And now it's 3-dimension surface, and do the plot. Suppose t equal 1, suppose t equal 4, suppose t equal 9. Bueno, under this consideration, this is x squared plus y squared plus z squared equal 1. Oh, it's a sphere. It's a sphere with the center and the origin and the radius 1. Likewise, here is x squared plus y squared plus z squared equal 4. It's another sphere, but the radius 2. And here is the radius 3, no? So now the contour plot of the surface is a family of the sphere. Suppose one sphere here, another sphere here, another sphere here, and this is the, at least some view of the 4-dimensional function using level surface. And this is important, not only graphic, the graphic part. In the most complicated part that we study in this chapter, sometimes it's convenient, very, very convenient. Suppose level surface to compute something that you don't know now. Instead of the classical surface in 3D. This is surface in 3D, but you consider that this is coming from level surface of the 4-dimension figure. This is, so mathematically, is nice to see that. One more thing I need to explain. Yeah. Important. I forgot the most important part. Okay. So now, okay. I understand, Professor, but I don't see clear the application of this. Okay. Let me try. Always remember, for me, it's important concept and interpretation. So 3D of the 4D spatial object in different points. Yeah. This is not the only way to express it graphically 4-dimension. Some people prefer, for example, another way using color. So, okay, one typical example. I don't want to explain in detail this. So you see the infrared image. Can you see in the movie something? The soldier in the army have a special glass. Can you see? Entonces, you see que es red, green. Entonces, suppose que es temperature. Entonces, you have one figure, and the 4-dimension now is the temperature. Entonces, you see this graphic as a combination in 4D. It's a one possibility. Okay, let me explain that part. Application, level curve, application. And what is the idea inside the derivative? Differentiation, no? Differentiation. Suppose this is the level curve I create for you to explain some idea. You have A, B, C, and D, 4 points. Yeah, I want to find the derivative of this. Wow. Okay, let's start for A. Let's start from A. I use two colors. Suppose I am here in A. Yeah, I travel in this direction. Okay, by the way, this is X, Y direction, no? Lógica, ¿no? C es perpendicular to the board. Entonces, looking the number in the level curve 2, 3, 1, 0, negative 1, negative 2, negative 3. So you travel and you are in the point A. However, I want to investigate the rate of change, derivative, rate of change when you're moving from the point A to the right. What do you think? So derivative. Entonces now we are using a special notation. Look. We are using a special notation. Suppose F, pero derivative, no prime. Prime es cálculo 1. No. Es, you indicate the direction. So X, and the direction X. Evaluate at the point A. Okay, I don't know exactly where I know this level indicates the C value. C equals 2, C equals 3, okay, and so on. So what do you think? Okay, I don't want number. I want positive or negative signs. Okay, when you suppose that you are in the mountain and your level curve is 2 kilometers maybe. When you move into the right, the mountain is going up or is going down. So this is the point A. Okay, and one view, lateral view. This is my eyes. Look, this is my eyes. Here I see something like that. Yes or no? This is 2 and this is 3 maybe, no? Do you see or no? Do you see or no? A ver, yes, you see Ernest, this is it. Entonces es obvio. Looking the level curve, I can infer que this derivative is positive. However, what happened if in the direction Y of the same point? So I'm moving now. I'm using another color. This is the point A, but I'm moving in that direction. Okay, I'm moving in the Y direction. That is the reason is the rate of change in the Y direction. So it's important that you understand from now que the derivative depending of the direction. So in Cal 1, nobody explained this. Because we suppose only one direction, default, gets from left to right, and in the story. Now here we have infinity possibility of the direction. Okay, we study now the classical X and Y direction, no? But I promise that we study how we compute derivative in any direction. What do you think about I need participation, and you help me to understand this? Okay, no, it's complicated, but it's a little bit confused. What do you think about the derivative of the rate of change of the point A and the direction Y? Que es the green direction. Es 0. Very well. It's 0 because it's the same level. Okay, you select 2 points. For example, here, and you see que Z is 2. So you travel like that, it's 0. It's constant. Si it's constant, derivative constant is 0. Cool. I like that. Let's analyze likewise in the point B. Direction X and direction Y. Basically, be familiar with this notation, guys. F, derivative, direction. This X indicate no function. Function is F alone. In Cal 1, we prime it. Because default, you suppose one direction. In Cal 3, you suppose this notation. I want to explain more notations. But now it's not important notation. The important is the concept. And the point B, and F, Y, in the point B. It's positive or negative. What do you think? And the point B, when you're moving in the direction X, I see how the level curve increasing, no? Actually, in the point B, the level curve is negative 1, no? Negative 1, 0, positive 1. Entonces es obvio que increasing, yes or no? No too fast, but increasing. However, when you're moving in the direction Y, is you moving from level curve negative 1 and negative 2 and negative 3. Entonces es decreasing. Let's start. Everyone follow me? Do you understand this idea or no? Okay. Let's At least I want to show you, my intention today is show you the application of the contour plot. And the point C. Let's see what happened in the point C and what happened in the point D. Okay, and the point C, let me see. The point C is this guy. When you travel in the direction X, it's obvious you increase it, right? It's greater than 0. When you travel in the direction Y, what do you think, guy? I saw increasing also, no? Yeah, because for example, you are in the level curve 0. Suppose que 0 represents the level of the sea, and you're moving to the mountain, no? Those are increasing. Both are positive. And what about D? Well, D, I have no idea. D is in this direction. E in this direction. It's the classical direction, X and Y direction. And this direction is positive, I guess so, no? It's positive, yeah. Look, we have in the level 3, and we move into the level 4, 5. So you go to the peak of the hill, right? However, when you're moving in the Y direction, I suppose get decreasing, no? I'm not clear what happened in the middle here, but I use my imagination, no? So you are in C equal 3, and you move in the Y direction. I suppose that we have another level in between 2 and 3 gets 2.1, 2.3, entonces es obvio que decrease. Make sense? Make sense or not? Too complicated? Too complicated, right? Or no? No, I don't think so. Okay. So now, before, I erase or no? I can erase? What do you think? Opinion, just opinion. You let me know. What about second derivative? For example, the point A. Okay, the notation we are using for the second derivative is, look, suppose point A. Second derivative is xx. Okay, in calculus 1, we're using that notation, double prime. Or d2 dx squared, calculus 1. In calculus 3, we're using xx. What means xx? Okay, you differentiate with respect to x, and you differentiate with respect to what? The x twice, 2 times. F, y, and so on. And we can differentiate, you see in detail next class. You can differentiate x first and y second, or you differentiate y first and x second. This is unbelievable. Remember, when you increase in the dimension of the mathematical problem, it's more complicated, because we have more possibility. You have no idea what is the sign of the second derivative in here, in that point. Remember, what's the meaning of the second derivative is concavity, no? It's concavity. What do you think about that part? The concavity of the land is concave down or concave up? In that part. I suppose it's concave down, no? Because 1, 2, 3, Well, not exactly, not exactly. No, it's no inflection point, but es, es concave down, ¿no? Entonces es negative, the concavity. Okay, entonces the most important is the thing we study Friday. Friday, I suppose we start Friday. Differentiation is in multivariable we can differentiation in any direction. Look, in the point A, we have derivative in this direction, derivative in this direction, derivative in this direction, or derivative in this direction, or derivative in any direction, infinity direction, right? The classical direction is X and Y. The standard, to say so name. Okay, entonces the time that we have, we spend doing something new, because when we are ready to differentiation, since you are ready to differentiation, you need to evaluate limit, and multivariable. Wow, it's exactly the same limit in single variable, similar. Let me recall Cal 1. Suppose that we have limit when x approaches to a of the function of the one single variable f of x. This exists if you compute the lateral limit a minus is equal to one number and limit x plus is equal the same number. Si this number is the same, entonces the overall limit exists y es equal L. So basically, this is my plane, my x-axis. This is A. You approach it to the left and to the right. X approach to A minus means X less than A. Close, of course. And X approach to the A plus is X greater than A. See, both value is the same. We have no jump discontinuous. Therefore, the limit exists. Yes, equal the limited lateral value. Clear? This is Cal 1. And in Cal 3, the thing is more complicated. Because suppose that we have one function. The notation that we're using is you have z equal fx comma y. No? And you're using limit of the f comma y is equal to something, and x comma y approach to the specific point, a comma b. Wow, it's all repaired. You see it's 3D, this is in the graph in 3D, que the domain is 2D. That is the reason that we have two components. But see the graph is in 4D, and the domain is 3D, we have a comma b comma c, you have x comma y comma c. And it's equal to something. And this something is complicated to find. Why is complicated to find? Don't be scared. I want to explain everything that you need to know. Suppose that this is my domain, xy. And this is the specific point I want to approach, AB. Okay, this is y. So I need to find the limit. But in what direction? Look Cal 1. Cal 1 approach it left and right. But in this case, you can approach it to any direction. Here, 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 here. Infinity direction. And so you need to compute infinity limit, Professor? No. I want to explain technique to simplify. But the idea is clear. Si at least one trajectory failed, give me different value, L1, L2 not equal, the limit do not exist. This is the idea. Cool? Cool? Let me explain example. Two more blah, blah, blah. Let's move into example to investigate very well this. Example 1 of limit. Suppose compute the limit when the x comma y approaches to 0, 0 origin of the function x squared minus y squared over x squared plus y squared. Okay, this is the function inside. This is f of x. And you plugging in, always happen in the limit, guy, you plugging in, always. The first step to compute the limit is plugging in. Si the answer is 40, I finish. Because I suppose que the function is continuous, and si the function is continuous, que we study in detail after continuity, pero no, okay. Entonces now, the, 85% of the scenarios, the function and the limit coincide. And the limit is the same. It's the same. So you plug it in. Si the answer is one number, entonces I get the answer. Si the answer is indeterminate, in this case it's obvious because it's indeterminate because it's 0 square minus 0 square over 0 square plus 0 square is 0 over 0. It's because something happened weird, right? I need to investigate that. So one fantastic way is, we have infinity trajectory. Infinity trajectory. We have infinity. Oh, we have infinity trajectory. Why not? Let's take an easy trajectory. So along, let's take it along x-axis. Exactly like Galois. This is like that. Entonces es y0. X-axis, right? Okay. Let's say this allow me convert the problem of the limit in multivariable and one problem of the single variable. The limit is now limit x approaches to 0, que is the only variable que stay alive, because I assume que y es 0. Entonces es x squared divided by x squared. Because y is 0, plug in 0 here, plug in 0 here. And x squared divided by x squared is 1. And limit of 1, the constant is 1. Pero dice the answer, no. It's a lateral limit, no? Along this axis. Suppose now along y-axis, que es x equals 0. So you convert my problem in single variable. Now the only variable that stay alive is y. And y. And y approaching to 0. And you assume x equals 0. Entonces minus y squared divided by y squared. Because x is 0, 0. Wow. This is limited. You divide. It's a -1, right? Because y squared -1, negative y squared divided by y squared positive is -1, and limit is -1. So now you see clear that there are no coincidences. Therefore, that limit, the example 1 that the professor put here, is do not exist. So it's relatively easy to prove that do not exist. Because at least one lateral in any trajectory failed, it's not equal. So now the answer is do not exist, and end the story. And all we have, no. Sometimes no. I want to illustrate any possibility. Not necessarily today. Today a little bit, Friday. Example 2. Okay, good. Oh, another approach. Bueno, professor, pero entonces you need to prove 1, 2, 3, 4, 5, 6. No. Suppose along the line y equal mx. Que es any line passing through the specific point. Entonces you replace. Okay, you replace here. Is it limited? Entonces you replace x squared, stay. You replace y squared is mx. This is m squared, x squared. Divided by x squared again, plus m squared, y squared. Sorry, x squared. I'm crazy. M squared, x squared. The only thing I did was replace y for mx. And so now we have single variable problem, x approaching to 0. Okay, you factorization, for example, limited, and the x approaching to 0, and so you see, wow, x squared is common factor, 1 minus m squared divided by x squared 1 plus m squared. And this is cancelled. So you can, because the limit is not a function evaluated at the point, it's just approach it. And the answer is 1 minus m squared divided by 1 plus m squared. Interpretation of this idea. Well, the limit we have in the example 1, when they approach it to infinity line to the point, depending of the trajectory, because depending the m, the slope you select. When I select, for example, a horizontal line, the slope 0, the answer was 1, because m0, 1 divided by 1 is 1. This example. When you select undefined, to say is, you suppose that m is infinity, because a vertical line, and when you delete that number and that number, and it's a negative one. Okay, so now, so far, one fantastic way is approach it using the line y equal mx. And we get the limit dependent of m, entonces we are in big trouble. Do not exist. Right? Okay, but I want to illustrate today one example in which the answer do not depend on m. However, when you approach it to another curve, que no necesarily is a line, suppose that you approach it to the parabola, then the limit do not exist. Okay, to say, wow. So we need to prove infinity possibility. No. I want to explain another technique. This is just the beginning. Example 2. Okay, example 2 is similar. It's easy. Limit when the x comma y approach to 0, 0 of the xy divided by x squared plus y squared. Compute that. Well, let's do in the same technique. Let's do in the y equal mx. Entonces limit when the x approaches to 0, single variable now. And here you replace mx and you replace here mx. We have mx squared divided by x squared plus m squared x squared. Es obvio que es square factorization and cancel out. Limit when the x approaches to 0, mx squared divided by x squared parentheses 1 plus m squared. X squared cancel, and the answer is m over 1 plus m squared, because the expression inside the limit do not depend on x. It's only constant, and the constant is. One more time, we see that depending on the trajectory, depending of the direction, so therefore do not exist the limit, because m participate in the game. Cool. One more example, the last one. Okay, illustrate the idea of I explained before of the parabola. Example 3. Suppose the limit x comma y approach to 0, 0 again, but it's different. This is x squared y divided by x to the 4th power plus y to the 2nd power. Okay, let's apply the same idea. I like this idea, but I want to illustrate in this example that not always working this idea. Okay, let's do it. Suppose now I convert to the single variable problem. Is limited when the x approaches to 0 of the x squared mx divided by x to the 4th power plus m squared x squared. Okay, now we have limited when the x approaches to 0 of the m x cubed divided by Well, in the denominator I factor out x squared. Entonces x squared plus m squared. Wow, entonces you cancel out something. Limited. When the x approaches to 0, you cancel out 2 here and 1 stay alive, only 1. Mx divided by x squared plus m squared. And when you plug it in, and this one is m times 0 divided by 0 squared plus m squared. Es obvio que the numerator is 0 divided by something is 0. Wow, entonces I prove, guys, que when you approach it to the 0,0 using any line, it's the same. Wow, fantastic. Entonces I suppose que the limit exists is equal to 0. No, because si you approach it, for example, at the parabola y equal x squared, you replace y for x squared. Our limit now would be limited when the x approaches to 0 again. So it's x squared and y is now x squared. Replace y for x squared, x to the 4th power plus x squared a squared. Wow, entonces es limited when the x approaches to 0 of the x to the 4th power divided by x to the 4th power plus x to the 4th power, no? Because x squared is 4th power. Entonces es limited when the x approaches to 0 of the x squared divided by 2x squared. Combine enter. Simplification is 1/2. Wow, the parabola give me 1/2. That means if when you approach it to any line, you go to the same point, 0,0. Nice. However, when you approach it to the parabola, no. Therefore, the limit again do not exist. So the question fly in the air. Bueno, professor, entonces always do not exist. No. This is typical example I bring today to illustrate the complication of the majority of the scenario. No, the limit is one number. However, in the next lecture, we study different strategy, more sophisticated to compute the limit. Okay, in multi-dimension. No necessary approach to parabola, no necessary approach to the line, another more sophisticated technique can you get the limit. Cool? Okay, guys, so we finish for today at least. Remember, Friday I promise that one of the grade I will post it in Blackboard, no? Any problem, guys, that you have, any discrepancy, you contact with me, pero by email. I can explain, I show you the mistake, or no. I feel that this class is good. Okay, guys, so now, have a nice day.